Good evening, ladies and gentlemen. My name is Benjamin Howarth. I am an ASP Insider, part of the Microsoft MVP network. And today I'm going to talk to you about performance in the JavaScript era. So we live in some very exciting times as web developers and in the world at large. After all, I'm British. I couldn't not mention Britain is leaving the European Union. SQL Server runs on Linux. Who would ever imagine 5 years ago that SQL Server would run on Linux? Linus Torvalds said that the day that Microsoft makes products for Linux is the day I've won. He has. Donald Trump, sadly, is still Cheeto in residence at the United States. .NET and ASP.NET are open source. Germany are out of the World Cup for the first time in the first round in 80 years, and England won a penalty shootout. We are living almost in an alternate reality, and JavaScript somehow is a popular and widely used server-side programming language. I don't make the rules, but they are there. So, the first question when we talk about web performance is what does, oh sorry, that's from my job drafting Donald Trump's tweets. What does web performance really mean? So, if I were to ask you here just to raise your hands and think of the first thing that comes to your mind when I say web performance, what do you think of? Anybody? Latency. Sorry? Latency, network latency, great. Anything else? Sorry? Throughput. Again, network speed. Anything else? Time to first paint in a browser. Excellent. We can generally break this down into about 3 different areas. The HTTP request itself, how long that takes and what size it is. The server render, how quickly it is to deliver up an API endpoint or an HTML view. And lastly, the browser load and paint. Today, I'm going to talk about tools that help you measure the first 2 and a little bit about the last one. I'm not an expert in browser rendering engines nor in JavaScript execution engines in the browser. If you want full details on the last point, then you can look up Leah Veru, who sits on the CSS working group for the W3C, or you can look up Rachel Andrew, who talks a lot about JavaScript execution in the browser. We're going to talk mostly about the first 2 today. So, firstly, how do we measure performance? What tools do we use? What do we have available at our disposal? So from the front end, we have YSlow using Phantom.js. How many people have heard of or used YSlow? Couple of people. Oh, fantastic. Excellent. For those that don't know, YSlow was a tool developed by the Yahoo team that was also responsible for the UE framework, which was an alternative to jQuery back in the day. And if you're still using UE or you're still using jQuery, come see me afterwards. PageSpeed Insights, now known as Lighthouse. How many people have used or know about PageSpeed Insights and the Lighthouse project? Very few. Fantastic. So, Lighthouse is a new utility that's been built by the Chromium team as part of Chrome and Opera, and we'll be showing off how it can produce reports in various different formats that will tell you about performance and a number of other aspects of your site or app. And Webpage Test, which is an online hosted service. How many people have heard of Webpage Test? Couple of people. Okay. I will be demonstrating all 3 of these tools along with some server-side stuff. We'll be looking at JMeter. How many people have come across JMeter? Oh, quite a lot. Wow, that's impressive. Excellent. That's quite possibly the highest number of hands I've seen come up with JMeter. So JMeter, for those who don't know, JMeter's a load and performance testing tool built by the Apache Foundation. It's in Java, which means it's really bad on Windows, but we'll be going to be demonstrating it anyway. Mini Profiler and Glimpse. I'm guessing most people are .NET developers, and you'll have come across at least one of those. I'm pretty sure I don't need to see hands. I'll be demonstrating Mini Profiler in particular, which is built by the Stack Exchange team responsible for Stack Overflow. And lastly, obviously, you have your own custom logging solutions, Log4net, Serilog. I don't need to tell you how to set up a system diagnostic stopwatch. I'm pretty sure you all know how to do that. So, without further ado, let's start demoing some of these tools. So, this is a website that I am responsible for called verbier.com. And on the left there, you'll see a number of kind of millisecond counts. Now, that's Mini Profiler, but I'll come to that later. Up here, in my little browser extensions, I've got YSlow. And if I just open that, it then runs a number of different tests against your site. Now, we're just going to be doing this locally using local code, because actually this site got hacked earlier in the week, so it's currently offline. We're going to run this, and it's going to pull up a number of different issues with the site to do with HTTP headers and CSS and JS minification, and we'll run through that. And once it's run through all those various different tests, it comes up with a score out of 100. Now, unlike your old high school teacher, this won't give you detention. Your boss might, though. So there's a number of different aspects that can be improved. This gets a grade C to begin with. Out of 100, that's 72. And let's start with some basics. Make fewer HTTP requests. This page has 21 external JavaScripts. Try combining them into one. Hands up how many people don't minify their JavaScripts and CSS. Go on, you know who you are, the guilty parties. No one's brave enough. Okay. I'm not going to recommend a CSS or JS minification tool. Okay. If you go to npm, and if I just search minify, there are in excess of 1,700 packages to choose from that will compress and minify your CSS and your JavaScript. Pick one, use one. That I don't care which one, but use one. Okay? The only time it's acceptable not to minify your CSS and JavaScript is if you know you have good network connection. How many people here build single-page applications for okay? How many people build SPAs inside an enterprise-type environment, something like an internal intranet? Okay, one person. So you know that you have a guaranteed 1 gig Ethernet connection, and it's always going to be reliable, right?
Well, we are telecom.
Well, that, in which I need to say no more. Of course, there's the gentleman from T-Mobile. So everybody else, right? If you are building a mobile site or if you are building a mobile application, you should be minifying your stuff, because if you're lazy loading, what happens if the connection drops? What happens in London, for example? They have the London Underground, which now has Wi-Fi in all the stations. So I can sit on the tube and get, pass through station to station and get 20 seconds maybe of Wi-Fi. And then what happens when I hit the tunnel? Just as I went to page navigate. If you're lazy loading your JavaScript, I'm immediately going to be hit with some kind of error. Your application or your service is going to stop working. Bundle and minify your JavaScript, please. There are plenty of tools out there to do it. So let's go through the rest of the list. Let's see what else it recommends. Using a content delivery network. Now, this is good for a number of reasons. Let me just zoom out of that. There we go. There are a number of different things that are not on a CDN. Now, how many people here use Azure or AWS cloud services in any way? Okay, plenty. Brilliant. Okay, so there's a great reason for serving static content, images, JavaScript, and style sheets, particularly off a CDN, because if you set your cookies correctly for your dynamic content, if you put it onto a CDN, those cookies won't be transmitted. The request will be smaller. As a result, the response will be smaller. Not only that, you won't have what is a dynamic resource, say a virtual machine or a web service, serving up static content that can be better served by blob storage or Amazon S3 buckets and Cloudflare. One website I worked on in particular was the Formula E Motorsport website, which is a sister championship to Formula One. When I first arrived in their first season, they had 4.5 gig. Bear in mind, they'd only had one race at this point. 4.5 gig of static media. Now, because that's understandable, because they're a sports championship, their job is to deliver high-resolution photos, press releases, fan downloads, wallpapers, all those kind of things. But 4.5 gig was an absolute, piss in a bucket, basically, compared to what they were going to grow to. So we farmed everything over to Amazon S3, and we put in front of that the CloudFront CDN, because a lot of the traffic was coming from China, and top 10 penetrations for CDN in China was CloudFront. The bill for the first month was $67, but we could suddenly go from serving 10,000 people to serving 100,000 people, because we'd farmed off something in the order of 70 or 80 gigs worth of traffic off to a resource that was better designed to handle it. So use a CDN. It will reduce the size of your request. It will be cheap. It will increase your computing capacity and resource. So what else do we have in this list? We have add expiry headers. Now, none of the items in this site actually have any expiry headers at all. And as a result, if I go and reload this using DevTools to demonstrate exactly how bad this really gets, we go to Network, and I'm going to go Disable Cache, and I'm going to load this from scratch. And we can then count how many separate resources are loaded. Yep, there's a lot. All right, we're at, let's see, still hasn't finished. Oh, there we go, 91. Okay. Now that's also after I've actually compressed a lot of the CSS down. And some of those are also to do with mini profiler. You wouldn't have those on production. So now if I go uncheck that and go preserve log, more requests. And let's see how many we get. down to 152. Every single request, because there's no expiry, the browser doesn't know that it should cache it for a long period of time. So it just goes, great, I'm going to re-request it from the server. That's more traffic. That's more latency. That's longer paint times. Total time to load that page, 28 seconds. I always have one really bad website in your arsenal to demonstrate how stuff should not be done. This is a prime example. So there we go, 182 requests. That's the combined two. So yeah, that's 90 ROM requests on each cycle because there are no expiry headers. Add expiry headers to static resources that you know aren't going to change over time. We then move on to, what else? Put CSS at the top. Oh, look, a jQuery plugin has decided to drop a CSS file in the body. Now, what's really painful about this is that means all the CSS will load up in the head, and it will start painting the body at the moment it's got all of those. But one of those is being loaded dynamically, and that's actually slowing down browser paint. And I will show exactly how much later that one CSS file is costing. What else do we have? Minify your JavaScript and CSS. That's pretty much already been covered. And another interesting one, configure entity tags, e-tags. Now, has anybody heard of e-tags before or come across it? One, two, couple of people. OK, so the idea behind an e-tag is it's supposed to be a kind of marker that identifies the contents of the file, almost like a timestamp or something to say that this is valid at this point. And the idea for that is that when an e-tag gets served by a static resource, then the browser will save that e-tag. When it re-requests the same URL, it will send the e-tag with it. If the resource has changed, the e-tag will be different, whether it's a date and timestamp or whether it's an MD5 hash of the file contents, whatever. Okay? It will then send a 200. If the correct behavior for any server is if the e-tag that comes back is identical, then the HTTP response code should be what's called a 304, which means not modified. And that means the browser just goes, great, I've got it in cache, load it from memory. So not only that, it immediately truncates the body. It doesn't actually send any response body back. It simply sends headers, which is the e-tag and a 304, which, again, minimizes network traffic. So, and there are some other ones in here. Reduce the number of DOM elements. Yeah, this is a big and messy page. You know, this is the kind of stuff where paint times would be affected if you're still using table layouts. If anybody is still using table layouts, then I've got a shotgun out back for you. And of course, I mentioned use cookie-free domains, which links into using CDNs earlier. So this is YSlow, and what's great about YSlow is it isn't just a graphical tool that you can use to pick through all the various bits. It also comes as a command line utility using Phantom.js, which is a headless browser. Because as much as I can demonstrate all these tools that are there for measuring, right, what's more important is being able to measure over time with your builds. So you want to integrate this stuff into continuous integration, ideally. And in a really ideal scenario, you'd find if you have a negative impact on performance from something that you've built or deployed, you could actually fail a build. And I'll come to demonstrating that with a Docker image a bit later on. So this is YSlow, and it's been around for a very long time. It's not very actively maintained at the moment, but it is still extremely useful. So we will now move on to Webpage Test. So if you look up here, there's a nice new little tab called Audits, which has recently been added in the past few months if you're running a Chromium browser. And this is where the Lighthouse project resides. And there are five different tests that we can run. Performance. How long does this app or site take to show content and become usable? Progressive web app. Does it meet the standards of a progressive web app? Now that would mean, are you using service workers to ensure that offline connectivity still works? Best practices, does it follow best practices? Again, are you minifying your CSS and JavaScript? Accessibility, that's an entire topic all of its own, which I'm not going to address, but it includes things like alt tags in your images, ARIA attributes where they're necessary for things like navigation, so people on restricted visibility can still browse and use your service. And SEO. This is actually interestingly linked to performance. Since 2014, Google has been penalizing sites that are too large, too slow, and not mobile friendly. Okay? That is a direct impact on the page rank for a site. So SEO and performance do go kind of hand in hand. But for the purpose of this demonstration, we are just going to go with performance. Now, this does take a while to run, but it's got a lot of interesting little statistics. And one of the other things that Lighthouse does is the first thing it does is it tests your website in a mobile experience, and it deliberately simulates throttling on a 3G connection to test what it's like to be on a restricted data kind of package or experience. So one of the interesting things that this does pull up is that as it's running, it runs through various stats and things. And one of them is that 75% of the world is still on only a 2 or a 3G connection. Right? We're lucky. We live in Western Europe. We've got fibre internet at 80 meg. Well, we have in the UK in certain places. We've got 4G connections at 8 meg on our cell phones. Some of us have got unlimited data packages, but that doesn't apply to 75% of the world. And one of the key examples of this was that YouTube launched an experiment called YouTube Lite. A very shrunk down, non-high res images, no ad tracking, no pixels, anything like that. And they discovered that the average load time accessing the YouTube Lite experience went up, not down. It wasn't faster. The reason is because people on 2 and 3G networks previously couldn't access the high-res experience at all. They'd simply try and get it, and within 5 minutes, they just go, nah, sod this, I'm not watching. You know, I've lost interest, I can't access this at all. It's completely inaccessible because of its size. The average load time went up because suddenly they could access it. So suddenly an entire swathe of audience across sub-Saharan Africa and Asia, and people who were on, you know, cheap feature phones and stuff could still actually access the service. The size of the service made it inaccessible previously, and the load time made it inaccessible by shrinking their resources and optimizing for performance. YouTube suddenly found they had an extra 100 million visitors from around the world that could actually watch their videos and subsequently watch their adverts, which is what YouTube makes its money on. So now this tends to take a bit of time. Oh, there we go, now it's run. First meaningful paint is at 4.3 seconds. Now there's a number that's used a lot in both user experience and in performance, and this number is 600 milliseconds. Okay, it's a bit of a golden point. And it's at that point, if you can deliver something within that 600 milliseconds from a user requesting an action, it feels instantaneous to the user. 600 milliseconds is the golden marker. Anything slower than that, and the user thinks it is a degraded experience, and they're more likely to lose interest. One of the statistics that is quite interesting that Lighthouse does pop up sometimes is that Walmart, for every 100 milliseconds they saw in performance improvements, saw a 1% uptick in revenue. Now think how much money Walmart makes. That's a lot, just for 100 milliseconds. That's, you know, a few million quid right there, right, for 100 milliseconds. So Lighthouse demonstrates a score, again, out of 100. This one, because it's running on my laptop, scores 41. If you run it against production, when it's working, it's even worse, because it's on a shared server with about 300 other websites. So, first interactive, the first time that someone can actually touch the screen and scroll through and actually do stuff, 15 seconds. Yeah, that's horrible. That's way off our 600 millisecond mark, right? So, and it gives you information about what you can do to improve it. So you remember that one style sheet I told you that was loading in the body? Yeah, that shadow box, little jQuery plugin? Okay, here we go. Oh no, that's a different one. Actually, that entire CSS file is taking 1,000 milliseconds to actually render, because there's so many complicated CSS rules in there that it's actually taking an entire one whole second just to actually read, understand, and paint, because it's too complicated. The reason it's not more is because I've bundled it recently. So on production, it's not. Server response time, now that's my laptop, but other things. Let's see, minified JavaScript, I've lost 200 milliseconds. That's a third of our 600 millisecond target, just wrapped up in JavaScript not being minified, right? And there's loads of other pointers in here as well. I mentioned about expiry headers. Uses inefficient cache policy on static assets, 42 items found, which includes jQuery, 41 kilobytes. Yay! Oh, I hate jQuery. Oh, what's even better, this one goes even further. If I scroll down, it's not just using jQuery. Look, it's got mootools in there. Anybody remember mootools? Yeah? Anybody remember mootools? Yeah? Remember that? Right, so I haven't got just one UI framework, I've got two, which are potentially blocking each other. Why on earth have I got that in there? I told you, always have one website that is an absolute example of things not to do. So, So this is Lighthouse, and it gives you a really nice report into everything that's causing problems and ways in which you can approach that. Another good one that's down here is, where are you? Off-screen images. No, it's not that one. There's normally a nice little highlight which says using new compression formats for images, such as, has anybody heard of WebP? Has anybody heard of WebP? No? So WebP is a kind of extended compression format created by the guys at Google because they come across these problems. It can gain, if I demonstrate what a WebP image looks like. All right, so this is a nice little sample I've got. I've got a PNG there, which basically looks like that when it loads. Oh, wrong screen. Nice little logo, okay? And the same image in WebP, that's 28K, WebP is 7K. 75% improvement straight away. However, it's only supported by, guess who? Chrome. And in fact, Edge have recently just added support. Safari might be getting on board, but then Apple likes doing its own thing. So Apple does, however, support another compression format called JPEG 2000, which is more widely supported as well. So if you can use newer image formats, kind of do browser sniffing and serve up smaller assets, even though they're effectively the same thing, do. Another thing I was going to mention about minifying your CSS and JavaScript, has anybody come across the technique of base 64ing your images? Yeah, a couple of people? Yeah. Where you take the data and you embed it as a URL. That can affect paint time substantially. So we're going to open this. Let's get you open. Opera, yeah, let's go. All right, so we've got that. So that's a regular style sheet with a regular image request with an image 100 times. So I'm going to quickly run DevTools and move wrong way, and we're going to go network. All right, so we've got the regular. Where'd you go there? All right. Oh, that's far too low for me to actually get a result. No, it's because, hang on, disable cache. Let's try that, and I'm going to throttle this as well, just to make it even more difficult. Because this really gives you an idea. Once you start throttling stuff to say, right, we're actually working on mobile devices, you want to start testing performance against mobile devices. We all build mobile responsive applications or websites. Your testing should include some performance aspects to do with that too. So all right, so we've got low-end mobile, and we're just going to reload that. All right, how long does that take? 164 milliseconds with the DOM content loaded of 108. All right, now this is base 64. For those who don't know what base 64ing is, the difference between this style sheet and this style sheet looks a lot bigger, right? So that's the actual raw image data converted into a base 64 string, basically, but it only makes 2 requests instead of 3, because you'll notice that the information, if I just quickly load that again and move that over, and then we go network, and let's see what we got on the paint time. Low-end mobile, reload, 150 millisecond, DOM content loaded 117, and yeah, it looks larger, but the actual time, the load event actually happened faster because it was base 64'd, right? Even though by base 64ing it, you end up with a larger style sheet. So think about things like little icons, backgrounds, all that kind of stuff. That's the kind of stuff you want to whack into base 64. So again, reduces the number of transactions, number of HTTP requests, but ultimately results in a faster payment time. So those are tips and tricks, and again, you can get a Node plugin to basically find URLs for things like fonts, images, and base 64 them automatically as part of your build pipeline. I'm not going to recommend one. If we go back to Node, and I just look up, base 64 CSS. Oh, I misspelled that. Base 64 CSS. 137 packages. There are tons. Pick one, use one. Also evaluate the network latency versus the paint time, because you may result in larger style sheets, which may, depending on your environment, be different. So pick and choose your tools carefully, but it's certainly one tool in your arsenal that should be there, or you should be at least considering it. So now we've covered all of those little bits and pieces, and we've covered what Lighthouse does. We're going to move on to Webpage Test, which I love. This is a fantastic tool that demonstrates quite possibly one of the most important things when talking about performance ever, basically. So a quick show of hands, how many people in this room have an unlimited data allowance on their mobile phone contract? One. Well, yeah, says the guy that works for T-Mobile. Right, me too, actually. And I don't work for T-Mobile. I have an unlimited data contract in the UK. It costs me about £85 a month, but I kind of need it for the work. So where this gets really cool, webpagetest.org, and we pull this up. Excellent. There we go, full screen that. All right, so I'm going to test my old site, formulae.com. Now, thankfully, these guys have optimized very nicely because I left them with a really sweet toolkit about, what would that be now, 3 years ago. They're still running on the same AWS architecture I set up. They're still running CloudFront. They're still running the minification. And they're still running the same underlying code, too. So, Webpage Test allows you to test from multiple locations around the world. Actually, you know what? I'll quickly jump back. And if I zoom in, right. Come on. There we go. Right. So Webpage Test allows you to test multiple devices, Android devices, Apple devices. It also allows you to test different environments. So you notice there's Dulles, Virginia. That would be on a ThinkPad using Chrome, Firefox, and Edge. So you can test in multiple browsers, multiple platforms, and multiple locations. If we go through the whole list, we've got, let's see, North America, South America, Europe, Africa, in Mauritius, Middle East, Asia, Oceania, Sydney. You can test from different places around the globe, basically, and subsequently get some real insight into where users in certain regions might actually be having problems with your service. So we are just going to stick with the defaults for now, and we're going to run the test. And is that a storefront? No, that looks like a church. Yeah, that'll do. Thanks. There we go. Running. So there is one feature in Webpage Test that is the absolute killer that I love more than anything. And when it comes up, there we go. What this also does is just like DevTools does, it gives you a full waterfall breakdown of all the connections and how long each one took as well. So, and it runs the test 3 times. So you have a proper kind of average across all 3. Here we go. Right. First byte. 0.14 seconds, that's good. Start render, 2.1, not great. Load time, 11 seconds, definitely not great. Although having said that, the average on a 3G connection is actually 14 seconds, so that's not bad. This is the killer feature, cost. Now, I mentioned about expiry and e-tags headers earlier. Right, that page weighs 6.1 megs. Accessing that one page on the average post-pay contract in Canada costs 75 cents just for one page. Now have a think, just walk through this mental process with me. You're using Amazon, okay? You hit the Amazon homepage, 1 view. Search for product, 2. View the product, 3. Add to basket, 4. Back to the homepage, 5. Search, 6. Product, 7. Basket, 8. Shipping, billing, credit card, thank you, 12 pages. 75 cents. That's just cost $10 with the wrong caching strategy just to access a very simple procedure that we do every single day and we take for granted. $10. That is very expensive. That's only in Canada. But you've got an entire list here. Let's have a look. Let's see. United States, it's not much better at 39 cents. That's still too much. 12 pages still comes in at what, $6? Just for basically placing an order with Amazon, if that did not have the right caching strategy. Thankfully, they do, because I taught them well. But that first homepage, oh look, Netherlands, there we are, 24 cents, right? That still comes in at what? That's still what, $3 for the entire, for that entire 12-page step, if that caching strategy is wrong. So use your expiry headers, use your e-tags correctly, and that cost. Sorry? Yes, well, here's the thing. A lot of countries do operate limited services. So you can also compare the difference between postpaid and prepaid. So in the United States, if you're on a prepaid contract, that page just costs you 60 cents. If you've got a prepaid T-Mobile or AT&T or Verizon SIM card, still 60 cents. Average cost, taken from all mobile phone providers providing a minimum data allowance of 500 meg over a minimum of 30 days. Okay? So these are all weighted and adjusted according to each country and each provider. So that's still expensive, right? This is why performance matters, is because there's a cost that you can't see and it's a cost to your users. If it costs them, they will realise that it is expensive to access your website over time. No one gets a full history breakdown of everything they accessed on their mobile phone. Right? I frankly think they should, because actually this would give them a really good indication of exactly which websites are causing the most damage to their data allowance. So that is ancillary. That's called whatdoesmysitecost.com, and it's part of Webpage Test. So, and again, Webpage Test comes as a command line tool courtesy of Node.js. So, and we'll be going into that in a little while. So, all right, so we're back to JMeter. And a lot of people kind of threw their hands up and said they knew what JMeter was. So for the few people that don't, I'm just going to do a very simple demonstration. All right, let's pull you. And for this, I'm actually going to duplicate my screen, because for some reason, JMeter doesn't like working on a separate screen. Here we go. And yeah, this is a Java-based tool, which means it sucks on Windows, but yeah, exactly. We try not to talk about that, but this is a massively powerful tool. So what we start off with is setting up what's called a thread group. And this basically allows us to pretend to be a certain number of people over a certain period of time. So for this example, we're going to pretend to be 200 people, and we're going to ramp that up as if it's progressive traffic, you know, people organically coming in over 30 seconds. And then we're going to execute whatever we want to 50 times in a loop. So that's 10,000 separate requests that this thing is going to launch and go with. Then we're going to add a sampler. Now, this is where the real power of JMeter does come in. As much as it is Java-based, because of this, this is a crazy good tool. The number of types of requests you can make. You can load test FTP services, web services. You can test your database scalability using JDBC. You can even, if you really want to piss off your network guys, go for raw TCP data right down there, right? For today, we're just going to demonstrate an HTTP request. And for some reason, the mouse and keyboard refuse to work nicely together. And we're just going to go HTTP protocol, and I'm going to go slam the Formula E website and make them panic for 2 minutes. It's fine. They do sampling on the Elastic for over 5 minutes, so this will barely touch it. So, and then we just go, lastly, we actually want to see what the result's doing. So we add a listener, and I'm just going to add a simple graph. And again, the keyboard does not work in conjunction with the mouse. Yeah, right. Yeah, Java UI tools aren't great. Okay, all right, so, and here we go. No, I do not want to save my test plan. And up in the top right, you can see the number of threads is rising, and we're starting to get requests in. So, let's see, we have average 400, median 300 seconds, average 500 milliseconds. That's pretty good. Because right now, there's not a race on. It's not a weekend, so they haven't got multiple servers. That's one server handling all of that. That's pretty good. So throughput, 5,000 requests a minute. That's not bad either. That's probably more capped by our Wi-Fi than their infrastructure too. So anyway, we're now about a quarter of the way through the test, so I'm just going to shut that down. But that gives you an idea of the graphing, what you can get, basically, from JMeter. And we stop that. And because Java is Java and doesn't actually shut down nicely, we'll shut it down the hard way. So that's JMeter, and what's great about JMeter is that that test plan that you saw can be saved as an XML file, and then you can actually send it out to what are called slave agents. So if you use the cloud frequently, which a lot of you do, you can actually get a JMeter slave agent and send it that XML file, and it will run the test headless for you and report the results back over a kind of, I think it's an RPC call, basically. But that means if I wanted to replicate instead of 10,000, if I want to replicate 100,000, great. I can set up 9 extra images, feed them that JMX, get the results 3 minutes later, and it's cost me, what, cents to rent that VM for, what, 3-5 minutes running that test. So, and it means I can properly test 100, 200, 500,000 people slamming my service. The other thing as well is because it's an HTTP request, it's not just limited to websites. You can use it for web APIs as well. So it supports the full gamut of HTTP headers. It supports get, post, put, delete, head, options, all the rest of them. So you can use it for fully testing any, at scale, any service, whether it's intranet inside your own company or whether it's public, you can use it for basically slamming through requests. Another powerful feature is you can actually load up CSV or XML data and throw that through so you can test how it handles invalid or valid requests to your API endpoints. So it's a great way of testing the resilience of your network and the speed of your code. But the key thing, once you've identified a slow part of your site, you obviously want to go into some detail as to where it might be. And this is where I pull open the local version, and this is where we look. Oh, and my DevTools still open. I've got a hunch my DevTools are still open, which is why it's locking that. Nope. Okay, fine. Here we go. And let's close. Yeah, let's just get rid of that. Right, so this thing on the left here, this is Mini Profiler, and I love this tool. It, as I say, built by the guys at Stack Exchange. This gives you full insight into your entity framework connections, your MVC views, anything that basically is available. It's not really a web API tool for that. You probably use Glimpse, but I have no hands-on experience with Glimpse, which is why I'm not demoing it today. So, but we'll take a look at Mini Profiler. So our homepage is taking 1,817 milliseconds just to spit out the HTML. So that's even before the paint gets there, right? This site runs on Umbraco, which comes with Mini Profiler bundled, but it works in MVC, it works in web forms, it works with entity framework wrappers. It's got a Raven DB wrapper. It's full, it's fully supported across the entire ecosystem. So, but yeah, that's slow, right? I mentioned that 600 milliseconds. We are 3 times over that, and that's just from the HTML. What's great is that this gives me a view-by-view breakdown. So there's one template, the header, that's taking 800 milliseconds just on its own to spit out the HTML. Why? I can tell you why. Dynamics. Anybody use the dynamic keyword in C#? Here. Couple of people? Okay. Right, 1, 2, 3. Were you using it for handling JSON?
Yes.
Yes? You're the maybe? You weren't using it for handling JSON. I am about to come to you in a minute. I'm picking on both of you for this. Right. So Umbraco uses Dynamics as a way of being able to get data fluidly out of a content management system. When I first came across the Formula E website, I pulled down the code. It wasn't even in Git at this point. Bless them. They really were absolute ingenues to all of this. Pulled it into a Git repository, ran it on my i7 laptop, 24 gigs of RAM, SSD, 4,200 milliseconds to spit out the HTML. Just on my laptop, not even under load or anything. No wonder they couldn't handle 10,000 people during the race in Beijing, where actually 250,000 people were trying to watch it. One file, one view, was taking 3,500 milliseconds on its own. It was a carousel. Those nice little sliders, you pull out 5 images, show them on a jQuery slider. It was using Dynamics. Dynamics is, when you use the dynamic keyword, it inherits from an object called dynamic object in the runtime. And when you're trying to access a property or a method, it's basically a giant 20 roughly level try-catch block. Now, obviously, we know try-catch raises exceptions. So it tries to get a field, catch, raise an exception. Even if one's not declared, one will be raised. Okay? Then it will go to the next try, catch, and so on, and so on, and so on, and so forth. Okay? If you're using JSON, if you don't know the schema for the data that you're working with, this is acceptable, but this is the only acceptable reason. If you know the data contract, use it, because what we did is we switched to static typing. The entire homepage from 4,200 milliseconds shrunk 146 to get HTML out from 4,200. So, you're using Dynamics, not for JSON. It's fine, I'll come and work with you to get rid of it, because you need to get rid of it. It is horrible from a performance perspective. It throws additional memory, it throws exceptions. You should not do it, ever. And Mini Profiler helped identify that part in the site where we need to get rid of it. So that's Mini Profiler. So you've got an idea of all the various different tools that can kind of measure your performance. Now, next question is, how do we improve it? And I've covered a few of them. Yslow's obviously pointed out some things, and so has Lighthouse. So, but this list is fairly long, and it's longer than Robert Mueller's subpoena list, and it's also longer than the list of women that Donald Trump has sexually harassed. So, I mentioned the 3 buckets that we have: request, render, and browser paint. Make your request as small as possible. Move your stuff to Blob and CDN. It's cheaper than a coffee per month. AWS gives you 5 gig of storage. CloudFront gives you 50 gig of network traffic per month. Okay, this stuff is free even after the 12-month expiry period. Use it. gzip and deflate your static resources. Okay, people. Sorry, any opinions about Brotli? Not widely supported yet. So, looks promising, not widely supported. When it is, then yes, use Brotli. But again, Brotli is a compression algorithm invented by the guys at Google, which appears to get, I think it's about a 30% gain over gzip, something like that. But again, because it's invented by Google, it's not widely supported as a it's not been ratified as a standard, and therefore it's not widely supported as a compression algorithm. So gzip and deflate, however, have been. They've been around for decades. So use them for your static resources. Dynamic ones, web APIs and HTML, use at your own risk, because there is a security vulnerability called crime and breach. If you are compressing dynamic resources over an HTTPS connection, over SSL3 in particular, I think, basically the compression algorithm can be used to reverse engineer the SSL encryption. So if you're then delivering user authentication tokens, session cookies, it can be hijacked. So if you're working on an internal app, right, absolutely fine. You know that no one's really going to be hijacking your internal network stuff. That's fine. Public stuff, don't do it. It's not worth the hassle. So, but your static resources, absolutely fine. That should be part of your build process. So, enable caching on static resources too. I mentioned both expires, headers, and the e-tags header. I will mention the cache control header because that one's a bit interesting, because certain proxy and routing devices can actually misinterpret it. It's not really, let's just say the implementation of the RFC around that header is flaky, depending on the manufacturer of your networking device. So I recommend not using it because I'm not a full expert on it, and you can never be entirely sure of whether something in your corporate network is actually interfering with that header and subsequently caching stuff that actually has staled or expired. That does sometimes happen if it's if both the device and that header are misconfigured incorrectly. So I say caveat emptor to anyone who wants to use cache control, but expiries and e-tags are both two easy things that you can do straight out of the box. In fact, expiries is literally, it's one line in your web config, basically. That's something you can throw in there for static resources straight away. You can do it today, and it will immediately start yielding results. Reducing asset size. Minify your CSS and JavaScript. As mentioned, there are tons of NPM packages. There are tons of MS build tasks that will also do this for you. Don't lazy load unless you will know it work reliably. If you're working in an enterprise environment with a 1 gig network, that's fine. If you're dealing with mobile audiences, bundle everything. Don't rely on lazy loading because, as I say, it will lead to a detrimental experience. Use an in-memory cache to boost speed. This is one thing I haven't addressed. If the system itself doesn't work as fast as you want, find a way around it. So, this is another project I worked on, which is for Universal Music Studios. 26 record labels, 2,500 artists, 164,000 unique pieces of content. This site is big. The DB backup alone was about 8 gig, and handled traffic of roughly 3 million people a month. But one major problem we had is getting the news articles out, because different record labels, different artists, different areas of the site all publish different news, and some of them actually had to end up on the homepage. Now, the query to run that across the CMS was so enormous, we ended up with about 5,500 different records, but because of the size of the in-memory object, it literally timed out. So what we did is we stuck it on a background thread, and so when we deployed, the app pool would recycle, the background thread would kick in, start doing the index for us, and then it would dump it in a Raven DB. And we did that because it was faster to query the Raven DB and sort stuff by date than it was to actually run the query directly against the CMS. So things like Raven DB, Memcached, I'm trying to think of some others. If MongoDB is your thing, I'm not a fan of Mongo, but use caches. No SQL databases are particularly good for this stuff. Oh, what's the other one I was thinking of? That's the one, thank you. Whoever said Redis, yes. Yeah, Redis, Memcached. If you're going to use Varnish, be careful, because Varnish acts as a proxy, so it actually caches HTML responses over the server. But when I started at Formula E, they'd used a Varnish server to try and keep the site online, because obviously there was that 4,200 millisecond bloody homepage. The Varnish server was misconfigured, and it actually started leaking data that people had put into forms, emails, Yes, emails and passwords. 25 grand fine by the Information Commissioner's Office, and I got the guy's job. So be careful knowing how to configure the tools in the right way, especially things like reverse proxies like Varnish. So, but do use tools like that correctly. Learn how they work and use them where it is appropriate. So yeah, so those entire 3 columns, it doesn't look like much, but that's powered with a data store of probably what is probably now in the order of about 10,000 news items, all coming from a Raven DB. The rest of it's coming from the CMS. So, and we go back and send 304s wherever possible. Always send 304s. If you know that the resource is the same, don't send it again. Just send a 304, end the response, and let the browser move on and do what it does best. So, server render, I've already covered JMeter for load testing. I've covered Mini Profiler. Don't use dynamics in .NET. Again, I'm looking very pointedly at the 2 gentlemen who were brave enough to raise their hands. That is going on my tombstone, I swear to God. Do not use dynamics in .NET unless it's JSON. That is your only acceptable reason. If you know the contract serialize, it is faster, and everybody will thank you for it, including future developers. I always like to say, we all know the axiom, which is act like the next developer who comes after you is an axe-wielding maniac who knows where you live. If I know you're using dynamics, I am that axe-wielding maniac. Nice to meet you. So don't use dynamics in .NET. And lastly, now we've talked about obviously how we measure and how we improve. Now we want to go on how to monitor, because performance is not something you can just say, oh, we've added this one toolkit or this one process, and now we're doing performance. How do you monitor? Because after all, you want resilient, strong and stable websites. Couldn't go without throwing my Prime Minister in there. Why not? Keep continually monitoring. New Relic. How many people have come across New Relic? Excellent. For those that haven't, New Relic is a tool that you install on an IIS box, and it inserts an HTTP module. It will measure your network traffic, it will measure your server render, and every single part of the application. It also works both, I believe it works as a Java agent, a .NET agent, a Node.js agent. It's got tools for every single platform. New Relic in particular, I was working with Universal Music Studios, and they had a custom-built, very interesting AngularJS app. And it was serving up both data and views using Web API and SignalR, which was a bit interesting because they were hooking it through to a Rhino service bus to then post to, funnily enough, the same Raven DB that powers the news section, except they were using it to power the online shop. So we found one particular URL was being really slow, about 3.5 seconds, 3,500 milliseconds, give or take. New Relic helped identify which URL, at which point I loaded it up, started going through, started debugging within my machine, thinking maybe it was the dependency injection container. We were using Unity, which can be quite heavy at times. And looking at this and going, this doesn't really make any sense. Jumped into the JavaScript end and discovered that nested down in the kind of root controller was a command. Once it had actually sent the SignalR command, it would then run a JavaScript callback and then close the connection. Now, obviously, because SignalR persists a connection until you actively tell it to close. Swap the 2 lines around. Server render cut to 200 milliseconds. It wasn't a server problem. It was a JavaScript paint problem with that callback. Threw it to the front-end developer, who subsequently had to lazy load some stuff later down in the page. But New Relic helped us identify which page it was, very specifically, that was taking a hell of a lot of time. And then I was, lucky enough to be able to find exactly why and where that was. So New Relic is an absolute lifesaver. They've got a free platform. It's well worth paying the monthly fee for, though. I want to talk about Gibraltar Soft Loop as well. Now, how many people have the misfortune of not doing ASP.NET MVC or doing .NET development, let's say WinForms or WPF? Absolutely nobody. Oh, one. Oh, poor you. So Gibraltar Soft Loop is based on PostSharp, and PostSharp is an aspect-oriented programming interweaver. It lets you create AOP frameworks and environments in places which don't naturally have them. MVC, obviously, and Web API, we're very lucky to have all that AOP goodness wrapped up for us. But WinForms and WPF and XAML guys don't have that. So PostSharp allows you to create aspects, kind of attributes that you can decorate your code with, which can subsequently then change the behavior of your code. And it does this by actually rewriting the IL as it's compiling. The guy who makes it, Geoff Pater, and his team are based in Prague, and if you ever get the chance to meet him, he is quite possibly the smartest .NET guy you will ever meet. Take a notebook if he ever takes you for a drink. You will learn tons. And Loop is based on that. It basically allows you to add logging aspects into stuff. It does have support for MVC. It also has support for other logging formats like Log4net and Serilog. So again, they have a free tier. It all goes up in the cloud, and they can tell you even which browser and which platform are having particular problems. So it gives you lots of insights. And of course, we can't go without mentioning Azure Application Insights. You have File, New, Web Application Project. There's even a tick box for it in Visual Studio, right? It gives you some basic information about response times and different stuff across URLs. I believe there's some extra paid things that you can get out of it as well. I haven't used it extensively because generally I stick with New Relic. That's by far and away my favorite tool of choice. And of course, for talking about continually monitoring, you also want to do continuous integration monitoring. So YSlow can actually fit into your continuous integration model, and there's a bug in it because it will output data in JUnit format, which can be picked up by any CI. But if you throw it multiple URLs, it puts the same XML into one single document, so you end up with multiple XML routes, which means you have invalid XML. It's not great. So I'm hoping to patch that soon. And then, of course, we have both PageSpeed Insights and JMeter, and the Lighthouse project also runs as a command line tool, as does JMeter. And I'm going to quickly show off a Docker image, which has got everything wrapped up in it. And when this is complete, it will be going on GitHub. It's not yet, so I'm going to walk you through this. Starting from the beginning, we're using an OpenJDK Windows Server core image, and then we're using PowerShell as our default shell. We then install Jenkins by default and set up a Jenkins slave. Then we add .NET and ASP.NET. Then we add MS Build. And then from then on, we then install the web targets, obviously to compile web applications. Then we install Git. Then we install JetBrains static code analysis tool. So there's even some command line stuff that's free from JetBrains, where you can do memory profiling as part of kind of your unit testing scenarios. And then lastly, we get down to NUnit and XUnit, and then we get to all the performance tools I've been talking about. We get JMeter, we get YSlow, we get AZCopy. That's a great little command line tool that just lets you throw files directly up to Azure. And what you can also do, I'm going to add some PowerShell scripts into this that let you set those expiry headers and those e-tags as part of your build process as well. So they're all set as metadata in Azure Blob Storage, and then they get fed through to the CDN as well. So it all kind of goes in nicely as part of your build process. Every time you run a new deployment, you throw your files into AZCopy, and then all the metadata is set for you. And then we get down to the fun stuff. How many people have heard of Chocolatey? Couple of people? Oh, excellent. For those that haven't, Chocolatey is a NuGet desktop package manager. So you can install exe and MSIs using basically the command line, using PowerShell, or just regular command line, in fact, as well. So it also does full dependency management in the same way that NuGet does. And we're using it to install Phantom.js, which is the headless browser that YSlow needs. We then install Yarn, because Lighthouse actually comes as a Yarn plugin, and Yarn is Facebook's version of NPM, basically. Because, of course, the whole point of open source is, oh, that looks good, but it doesn't do what we want. Let's build one just like it. Anyway, we then get to the Lighthouse module itself. I'm going to put a gist online, which will pull in because Lighthouse command line will output in HTML, CSV, or JSON. So I'm going to add a transformer that will then turn that into JUnit format. So again, it can be read by your continuous integration environment. We then install the NPM module for Webpage Test, and then we run some startup scripts. And the actual tests themselves literally take this kind of format. So you run Phantom.js, and then you run yslow.js with the local URL, -f JUnit. Lighthouse, the URL, _output equals JSON, or CSV, or HTML, and my plugin, my little gist, is going to add JUnit on the end there. And then Webpage Test, again, throw that in. Now, both of those modules have got stacks and stacks and stacks of documentation over at npmjs.com. Lighthouse and npmjs.com package webpage test. So Lighthouse obviously showing how you can use it in Chrome DevTools and all the CLI options. There are so many different options for setting things like throttling, which platforms you want to test, where you output your reports, which audits you want to run, whether that's just the performance audit or the SEO audit or the progressive web app audit, because as I mentioned, there's 5 different types you can run. So you can run all of these automatically using this module. So, and lastly, Webpage Test, again, with all the stacks of options that you can get for locations, devices, everything, how you want that outputted, and so on and so on and so forth. So all of these tools, I will hopefully have this Docker image ready soon, so you can literally just pull it down, run a fresh Jenkins instance, throw in your web application project, get that deployed to a URL using MS Deploy, and then start running these queries automatically. So you can start seeing what is your baseline, and that feeds into your CI. So then you see how your improvements, how you start applying this tooling, subsequently improves your performance over time. So the moment I have finished that Docker image, it will be going on GitHub, and I will be commenting in the Meetup group accordingly with that information. Other than that, that is the demonstration of all the tools, and that is the demonstration over. So if anyone has any questions.
Do most of these tools also apply to APIs, so not just to web pages?
I think so. I think the one that would apply mostly for APIs, you'd be looking at using Glimpse, and you'd be looking at using JMeter. So JMeter would be obviously measuring your API at scale. As I mentioned, in fact, I'll just pull up in JMeter now. See. And I'll show you all the various different options. Because as much as I showed off the kind of basic HTTP request, there's so much more it can do. So if we go add, thread group, and again, the keyboard doesn't work. I'll just leave the default option because all I want really is the sampler. And we go into HTTP requests. Here we go. So methods, here you go. Get, post, head, put, all of those different options. Where you can get really clever is you can add a config element and you can go CSV dataset. So I can then load in, let's say you create dummy data for your API, right? Okay, valid and invalid data. You can load that all in through a file name and then effectively batch push that through in there using variable substitution. There's a whole ton of documentation about JMeter. But yeah, then you can basically bulk test valid and invalid responses at scale and subsequently say, okay, is this fast? You know, which URLs have problems, why, and so on and so forth. So you'd be using that, and then obviously to accompany that, to then go in detail, you'd then look at installing something like Glimpse. Yeah, Glimpse. So Glimpse, I'll just pull open some information. So Glimpse is a bit like Mini Profiler, but it shows you traces of requests that have happened in the application pool, basically. So it will show you URLs and subsequently give you kind of stack traces of how long each step took. Glimpse.net. Yes. Oh, and that's one thing I didn't actually show in here, is in Mini Profiler, there's a section there that shows SQL queries. So if I zoom in on that, you can see how many queries are actually repeated as duplicates and which file is calling them. So now, obviously, this is a CMS, so a lot of these are repeated. And I'm not really fussed about a query that took 0.6 milliseconds, obviously. That's nothing in the grand scheme of things. What I will be concerned about is that, 14.2 milliseconds? Yeah, there's duplicates. Again, this is a CMS. Obviously, in custom applications, you'd be looking to remove some of that stuff. But this, again, this gives you an insight into the queries that are being run and what kind of stuff is being returned. Glimpse gives you a view of this, but basically via a separate URL, effectively an administration dashboard that gets picked up once you've installed it. Let me see if I can find it. Here we go. Get Glimpse. Here we go. Where are you? I'm just trying to find it. Where did it go? Profile and debug. Oh, here we go. Oh, it's in the Microsoft Docs. Oh, that's why it's an outer curve project now, isn't it? Here we go. So Glimpse, you install it as a NuGet package, and here you go. Extra support. You've got ADO support, EF6, MVC5, and then the dashboard. Here we go. So you get to this part where you can turn Glimpse on or turn Glimpse off, and it will start capturing requests. So you can then see, here you go, controller, action, category, type method, how long it took, and so on and so forth. It basically kicks in as a kind of browser extension, almost in the browser, in the same way that Mini Profiler does. So the reason I don't mention Glimpse that much is because as much as there's documentation here, One thing I have noticed is that the GitHub repo has been very quiet over the last 12 to 18 months. So I'm not entirely sure if they're planning anything like .NET Core support or .NET Standard, right? So I don't mention it. One, I don't have a huge amount of experience, and two, I'm not sure how alive it is as a project, you know? Every open source project kind of has a threshold where it gets over and it's maintained by the community, but it still needs leaders, and nothing seems to have happened much on this recently. So, but Glimpse would be good for what you're wanting for web APIs, because yeah, you would use it because there's a separate kind of admin area which will trap API requests, basically. So you'd want JMeter, obviously loading in CSV or XML data to test at scale, and then using Glimpse to be able to diagnose in explicit detail exactly where that slowdown is happening. So, and I think as mentioned on the blog, they've also got Glimpse Node now as well. They've got a Node edition, so if any of you are writing Node backend web services, yep, there is a Glimpse Node NPM package. And when was that done? I'm trying to look at the date on that blog post. 2017. See, here's the thing. Not much has happened since that date last year. Anyway, there we go. Package, Glimpse, Node edition. So, the guys that brought you diagnostic tool from .NET have taken it over to Node as well. So these are cross-platform, as I say, JavaScript era tools, you know, for measuring website and web app performance. So that's what I'd recommend for kind of API stuff. Does that help?
Yeah, sure.
Excellent. Any other questions? No? In which case, I revert back to Boris Johnson. Thank you for listening. Wonderful.
Thank you. This is a, I don't know if you like gin. So this is a sort of a Dutch gin with a stroopwafel.
I know, my girlfriend will love that. Thank you very much. Fantastic.
For attending and all this energy.
Thank you.
We have pizza. So
excellent.
thanks, Martha.